Hello and welcome to this interview. Thank you so much for joining me, Kufirre. I hope I pronounced the name correctly, but I'm just going to ask you to introduce yourself and then you can say your names correctly.
Thank you very much. My name is Kufirre Ebong. I'm an embedded firmware engineer. I've been working on firmware for about 6, 7 years now. Basically, what firmware is software that runs directly on the microprocessors of microcontrollers. It's closer to the metal than your regular application software and all that. Yeah, so that's my career. That's what I'm very passionate about, solving problems using embedded systems, and generally, making life better.
Yeah, and you're pretty rare, right? Finding an embedded firmware engineer is like looking for a needle in a haystack. I've been tweeting about it, just trying to find people to talk to, and it's been pretty difficult. So thank you once again for volunteering to get um, on this interview with me so that other Africans can find out about what working as an embedded firmware engineer is like and what the opportunities are there. And obviously you're here, so there are opportunities. Um, okay, so and you mentioned that you've been doing this for about 7 years now. So that's a pretty consistent period of time. So could you tell us what schools you attended and in what countries?
So I did all my schooling in Nigeria. I attended for my first degree. I attended the University of Port Harcourt. However, during my IT year, which was back in 2015, I I attended a training institute, Atopet Automations Limited, which is why I got exposed to microcontrollers and what they can do, the power of microcontrollers. And right after the IT period, I became sort of self-taught. So I was learning from YouTube. I was learning from Coursera, Udemy, pretty much anything I could lay my hands on. But then the most important thing about embedded systems, and you may want to argue any other field, is it's not just about learning, but getting to put to application what you learn, and so it doesn't become like a tutorial purgatory whereby you keep learning, you keep learning, you keep learning, and then you don't apply anything. So it has been me spending money on components, reaching out to a lot of people on LinkedIn, seeing that I was in Nigeria almost all my life, but then I wanted to be exposed to the world. So I connected to quite a few persons whom I consider my mentors on LinkedIn. And I'm so favored and so blessed to have very excellent mentors that are willing to invest time to, tutor me up until now.
Interesting. What country did you do that internship in?
I did my internship in Port Harcourt, Nigeria, Atopet
Wow.
Automations Limited.
Okay. That's really good news because it means that anyone who's interested can follow the same path that you took. Of course, the challenge now is, like you said, getting their hands on those components, purchasing development boards, being able to practice on them. That's where there's a bit of a challenge, but all hope isn't lost. Let's talk about the journey first of all, and then we'll talk about surmounting some of these challenges.
Great.
So you've actually answered the next question, which was going to be about how you got into embedded development. Like you mentioned, when you went for your internship, you got exposed to uh, these components, these microcontroller development boards, and you took it on from there. And during your internship, what boards were you exposed to?
Basically, at the internship level, at an introductory level, you would get to learn with Arduino. However,
Okay.
if I were to start over, I would not advise anyone to just start learning with Arduino unless you want to do this as a hobby. If you want to learn embedded systems as a career, never, never, never start with Arduino. You should rather start with the AVR chips, which is the main microcontroller. And because Arduino abstracts a lot of details from you and just throws you out with just very basic functions, and you can't learn to be an engineer that way. So anyways, I started with the Arduino and the PIC microcontroller. At some point, we moved on to Mbed, which we programmed in C++. Yeah, but then along the line, I got exposed to other MCUs like the ESP8266, the O1 version, which is just the simplest Wi-Fi chip. Yeah, and then I got exposed to the ESP32, STM32, then the Raspberry Pis, the Jetson Nanos, Orange Pi, quite a number of boards along the line.
Right. So it's interesting what you said. I think that from a learning perspective, one of the reasons why people get introduced via Arduino is just to give them a soft landing, kind of like to reduce the steep, right? Because it's a pretty steep learning curve when you think about it. Unlike with, say, regular desktop programming where you're doing one thing, which is you're writing code, you're dealing with input and output, but you're writing code. With microcontrollers, you're programming, but you're also having to worry about electronic components, right? So sometimes you have to deal with circuitry and things like that. And then to add to that, if the individual doesn't already have a programming background, then you're asking, am I going to be having to learn something and at the same time also learn what you might call a low-level programming language, right? Which is C or C++, depending on what you're doing. And I can only think about, how people might react if you said to them, learn C++, learn pointers, learn encapsulation, learn polymorphism, right? All of these things. And then at the same time, worry about digital inputs and outputs, worry about analog inputs and outputs, worry about I2C. I think that somewhere along the line, they're going to say, what exactly do you want me to focus on? So I can imagine, because if you go back to why Arduino itself exists, it was to teach people, right? Usually there's some sort of transitory phase, what you might call an onboarding phase between school and work, right? So typically you don't get thrown into the deep end. Like you don't just resume at work and then they're like, here, go and program the, the Boeing 737 MAX or whatever, right? There's going to be like, okay, here's what you know, here's what we are doing, here's the delta, here's the difference between what we're doing and what you need to know, and here's how you go from A to B, right? So yeah, I can imagine and understand that, you say to people, okay, start with Arduino, then at that point there's an abstraction, because the thing with like an Arduino is that on the IDE you're programming one thing, but recall that you set the board, and when you set the board, it then determines what sort of chip is on the board. So all of these chips that you mentioned are actually all supported by the Arduino IDE. You can program your, STM32. All Mbed OS is actually supported. Once they introduced the Arduino Nano 33 BLE, they had support for Mbed OS. They have support for the Raspberry Pi Pico as well.
Yeah.
Quite a few things, that are supported there. But you don't have to deal with all of those nuanced differences. I think that when people find a bit of, what's the word I'm looking for? When they're a bit more comfortable, right, then you can now tell them, okay, make use of the actual SDK that comes with this microcontroller board, and then you can get everything that you want done. Yeah, but so it's been an interesting journey for you. And
So,
do you mind telling us what? Go ahead, please.
okay. Firstly, if you don't mind,
Yes.
I would like, can we like sort of pause the meeting and then reconvene in like 30 minutes? I just got a quick call, from work.
Okay.
Is that an issue?
Okay. So let me ask again. You were going to tell me about the difficulty you've experienced as a result of starting off on the Arduino platform. Not just you, but some of your colleagues or friends. So please go ahead.
So great. If you plan to be a hobbyist and that's all you want to do, Arduino is perfect for you. It's great for you. You can do a ton of things. But if you plan to be professional and you want to do real engineering stuff, what Arduino does to you is that it hides the details of implementation from you. And then by the time you get to work with more advanced controllers, like STM32 and the likes, you'll find it very difficult because then you didn't know that to implement a simple delay in Arduino, which you just one line of code, but in a real standard 32-bit microcontroller, you would have to configure some clock peripherals, configure some timers, and then you need to understand how all those things are working together to achieve exactly what you want to do. Starting out with Arduino in that case would make you feel confident, whereas you really don't know so much about what the intricacies are. And you are a hardware engineer, you're not an application engineer. And so you need to understand your hardware. And Arduino doesn't help you do that. Arduino just makes things easy for you, and you just write a few codes. And as a matter of fact, even the Arduino programming, you won't exactly call it. It's more like an option. It's more like their own framework. Arduino is more like a framework. So some functions you might think you are calling, which are standard C functions, are not exactly C functions. For instance, there's no variable type as string in standard C programming. But oh yeah, that's a good instance. But so when you come from a long history of programming with Arduino and you're asked to write a simple code and you're asked to declare a string and you type string and nothing happens, you start getting confused. So I would advise if you're starting out, there are simple microcontrollers. You could even use the microcontroller on the Arduino, the AVR, but try to avoid using um, learning just with the Arduino development board. If you plan to take this as a career, take the AVR you take the AVR and understand how the architecture of the AVR is. It's simply 8 bits, and then learn how to blink an LED. Once you can do that by reading the Arduino datasheet, then that's a good start for you. It's not an easy start, but once you get it, then you can actually work with any 8-bit microcontroller because then you would have known the fundamentals.
Okay, that's pretty interesting. Thank you so much for that insight. I was going down memory lane as you were speaking because as someone who's coming from the software side, I started off with C. That was my first programming language. But I've done a bunch over time. I've done assembly language. So I've gone really low level, but I've also gone high level. And some of the things that you explained or you described, there what is simply called encapsulation, um, which is like, okay, to do X, you have to do 7 things, right? But if you have to do 7 things more than once, why don't you have a function that does those 7 things in that particular sequence? Which is what good programming is about. Yeah, and that's why even languages like C++, they've morphed over time. Like almost every language tries to improve over time, right? So I do understand what you're saying in terms of discipline, in terms of being able to say, I know that this thing that I'm using here doesn't exist somewhere else. It's the case with, there was a time I had to do a lot of context switching between Delphi, which is Object Pascal, C++, and Java, and I had to do that context switching across multiple operating systems. So I was working on a mainframe and I was working on a microcomputer at the same time. And there were things that you could do on the microcomputer that you just couldn't do on the mainframe. There were calls you could make. You couldn't make API calls on the mainframe. You had to use essentially queues at that point in time, right? So it was queuing that we were using and things like that. Message queues. So you just drop messages, and then you check for your responses and things. So yeah, I do understand what you're saying, because I think that even for most of the boards that have their own tool chains and their own IDs and their own SDK, but that you can program via Arduino, what they say to you is, look, for an easy start, yeah, go with Arduino, but know that you can't utilize all of the capability of the board, from Arduino. You then have to learn. I think part of the difficulty is in teaching, right? And for people like me, I don't know if you still remember, but I've been at this for pretty long, very long period of time. So sometimes I say to myself, have I forgotten what it's like to learn something for the first time? Right? I ask myself that question. So again, that is really maybe the question that people will also be asking, which is, do you know how hard it is for us to learn even the simple things, the things that you consider to be simple? Like, you know how hard it is for us to learn these things? And then now you're saying to us, oh no, go all the way down. It's almost like saying, today, if we're saying to people, in order for you to be a disciplined programmer, don't start with Python, right? Because Python doesn't enforce types and all of those things. Instead, go and start with assembly, right? And then they're going to be like, are you trying to gatekeep? Are you trying to just, be a difficult person? Do you really want us to do this thing, right? But that's just like segue, thinking about it from their perspective, like some of the questions that they might ask. But I like what you're saying, right? Which is, at the very least, know your C programming, know what is, ASCII, and know what is an extension. Like Arduino is an extension. Like how you would write Arduino is not how you would write ASCII C strictly, right? So just know those differences and then learn those. So for me, going forward, talking to the community, I think that's something I need to bear in mind, to say, so you need to know how this thing would work in this environment versus how it would work outside of that environment. Okay. Thank you so much for that. So I will ask the next question. What company and country do you currently work in?
I currently work in the UK for a company called Uni UK Limited. So what the company essentially does is we build an ecosystem around a pizza oven, or should I say pizza ovens. And so our job as firmware engineers is to make the pizza ovens to kind of like have some IoT functionality and to make them smart as well.
Okay, so I love this, because when I talk about microcontrollers and when I give people examples of microcontrollers around there, say you have microcontrollers in your home, you have them in the living room, you have them in the kitchen, and I usually give examples where, like, your microwave, your fridge, your washing machine, you have microcontrollers in there. And finally, we have someone on screen who is programming ovens, right? So that's wonderful. So Oni UK Limited, is that something you started or did you join afterwards?
Oh, I joined Uni. I have my startups, however, but then I actually joined Uni couple of months back. They have been
Okay.
there for almost 10 years.
Okay. And for your startup, do you care to talk a little bit about it?
Sure. My startup is Fuel Intelligence Nigeria Limited. Um, um, we design a hardware that latches onto filling stations and captures all the data about sales, volume, under the volume of the underground tanks, the sales activities, and then sends that to a web server um, using some communication protocol. And then it also uses RFID technology to authenticate tags on vehicles so that dispensing is only made to authenticated company assets like vehicles or trucks. And the whole objective is to curb fuel theft and to provide an automated inventory management system for filling station owners and also to make that whole process remote. So you can be a filling station owner, you have a lot of filling stations in Nigeria, but then you can freely travel around the world and monitor your businesses at the comfort of your tablet or your computer. So that's what Field Intelligence does. It's an early stage startup. We launched in November and we've gained some tractions with the NCDMB, with Meetstar, and we've had should I say, the blessing of traveling for GITEX in Dubai, which was last year in October. And by the grace of God, we're pushing.
So it's nice that, given that you did your internship in Port Harcourt, and Port Harcourt is the petroleum capital of Nigeria. All the oil companies are basically um, headquartered out of Port Harcourt, if I'm not mistaken. But like that's where the majority of operations for petroleum happens for Nigeria as an oil producing country. And off of that, you've thought of a problem, you've observed a problem, and you've come up with a solution for that. So I think for viewers, it's important to highlight the fact that you're solving two different problems concurrently. And that just goes to show how many problems there are out there that can be solved using microcontrollers, and to also state that there are people who are actually solving these problems. Um, and how long have you worked at Oni UK Limited?
I've worked there for. I joined in November last year, so I
Okay.
actually just relocated to the UK in September
Okay.
last year. Uh, I was, should I say, favored to have had such a beautiful company as Oni in just about 2 months.
Okay. Nice. Um, so are you able to tell us at Oni what microcontrollers do you prototype on? Is that something that you're allowed to talk about?
Of course, yeah, because I mean, you could take it apart and still look at the microcontroller if you wanted to. Yeah, so
Yeah, but
it's
either
we're current,
if
yeah.
some legalese that says don't talk about it, then we will not compromise your relationship with your employers. But please go ahead.
So basically, the main controller we're using is an ESP32.
Okay,
Mhm.
nice. And how about back at Fuel Intelligence?
Back at Firm Intelligence, I have had the chance to move from a Raspberry Pi Model 3B single board computer to a Raspberry Pi compute module
Okay,
to a currently an ESP32.
okay, okay. So you've fallen in love with the ESP32.
Very, very much.
And what IDEs do you use for programming the ESP32?
For the ESP32, the recommended ID would be Eclipse, but a very convenient one, platform IO on Visual Studio Code. So Visual Studio
Okay.
Code is more of a text editor, but then with some platform IO, it makes it a very powerful tool for programming the ESP32.
Okay. Lovely. And are you able to share with viewers what the entry level salary for an embedded systems engineer or an embedded firmware engineer in a company like yours, so that's only UK Limited now, what an entry level salary would look like?
Entry level would be somewhere around 27K. And
Okay, so that's
27K is very, yeah, it's sorry, 27,000 pounds. So sorry. And
it's fine.
that's pretty decent.
We deal
That's
with
pretty
people.
decent.
We deal with people in different countries, so you just have to state what the currency is. So anyone who's
Yes.
saying, okay, I'd like to be like Kufri when I grow up, maybe in 2 or 3 years' time, and if I want to work in a similar company, not necessarily the same company, but and in the same country, but similar company, what sort of salary would I be
Yeah.
aspiring to
Yeah.
as entry level? And so
Yeah. So if I
27,000.
would,
Yeah, go ahead, please.
yeah, if I would explain further, it's also largely dependent on the location where you find yourself. So
Okay.
if you are in somewhere central like London, you could have an entry level salary of 35K
Okay.
or even more. But where I am, because of course, there are like taxes and standard of cost of living which differ based on location, and that determines what entry level salary is. Yeah. But where I am, which is up north in Scotland,
Okay.
standard cost of living is pretty decent, so you don't need so much as an entry level engineer.
Okay. That's good to know. Um, and so that's 27,000 before taxes.
No, including taxes.
Yeah. Okay. Yeah. So that's before taxes, right? Not after
Before
taxes.
taxes, yeah. Sorry, before taxes.
Oh, all right. Fine. We're losing your video, but I can still hear you. So
Yeah,
hopefully,
for some
when we get
reason.
the recording, hopefully when we get the recording, we will have the video, your video in there. So let's just see how it goes.
Okay.
Um,
Okay.
so the final question, we've come to the final question, and I should say thank you so much for your time. The final question is, what advice would you give to aspiring embedded systems engineers or embedded firmware engineers?
Thank you. This is quite a good question for me. I would say never, never, never give up, and do not look at monetary value initially, but rather pursue resource, like the one that doesn't have to do with money. Get knowledge, get experience, and money will be running at you, because by the time you begin to solve problems with your skills, you're going to be sorted after. Yeah, because like you earlier on mentioned, Mr. Robert, embedded system engineers are very, very hard to find. And even when you find them, because embedded systems is really broad, so finding a specialized embedded systems engineer for what you want to achieve, it's another task on its own. So you have to just spend time and invest in buying boards. Don't just learn theoretically. Don't take courses. Forget about certificates. Do not learn for certificates. Get boards and try out things. Fail at things. Have problems that seem impossible to solve, but I assure you that there's always a solution for it. And in finding those solutions, you become a professional. It's better than learning from any school. And then also, if you can, try to reach out to people to mentor you, get mentors. It's helped me. That's helped me bridge a gap of a couple of years by just having a mentor to point me in the right direction. And so that would be my advice.
Okay, thank you so much, so much. We know your time is precious, but you've given us about 2 hours of your time because um, we had to do the interview in phases. But we appreciate your time so much. We're quite grateful We hope that this interview is going to inspire quite a lot of people on the continent to get into this field. And we look forward to having you come around maybe during the learning challenge that we're hoping to have this year and for some other events. So thank you so much.
Thank you very much, Robert. It's been a huge pleasure talking with you. And thank you.